Okay, I'm ready.
Okay, I make a clap.
Yep.
Yo. Hello, VJ.
Hello, Stefan. How are you?
Yeah, recovered from the show.
Yeah.
Some hard days, but also some good. And have you good trip back home?
Yeah, it actually was remarkably uneventful as compared to the trip out.
Yeah. Your luggage were postponed, and oh yeah, that was really a hassle. But finally, we did it.
Yes.
Yeah, yeah. After today, we gonna do a kind of after show tech talk.
Yeah. I mean, there's
Because
been a
after
bunch of questions that have come in from the
yeah.
internets, and maybe we can try to address some of those.
Yeah, right. And yeah, already collect some of them. And yeah, very good question. I definitely have to say, it needs also took me a week to wrap my head around understanding all those things and all the potential about this new stuff we introduced there on the show. And definitely some good questions. Well, we start with the first one.
Sure.
Um, I don't understand. This is an upgrade or a different box?
Yeah, so this is an upgrade. It applies to every unit we have ever shipped. And
Hmm.
when we said 13 years ago, we said that this box was going to be future proof, we really did mean it. Um, it's part of our design philosophy to build products that don't need to be thrown away, don't go out of date,
Yeah.
and as a result, we made the design of these products modular so that when a particular component within it sort of started showing its age, we could actually go and upgrade that to modern standards. So the whole idea of this is that the the stuff that we're talking about with this new system is something that applies to every box that we've ever shipped, and it allows every box that we've ever shipped to become part of this system.
Yeah. That's, I think, yeah, you can also, I think it's not just hardware. What I also realized is, for example, whenever Apple is introducing a new OS X, you already have the driver ready.
Right, exactly.
Yeah, that's something also what I would say. Mr. Mid is really special. Yeah, it's just an upgrade, definitely. And yeah,
Oh,
then,
and so I guess the other point is that part of that question is that, is it a different box? No, it's something that replaces the master board in the
yeah,
existing box. So it's
yeah,
not like, oh, now you need to have a whole bunch of things hanging off of your box and your computer in order for this to all work together.
yeah,
Uh,
it would be inside the box, definitely. Yeah, very important part.
correct.
Yeah. Yeah, someone who's not a visual image of the thing will maybe thinking about, okay, bunch of cables hanging around or something. Yeah.
Exactly.
Okay. No, very important. Yeah, right. Okay. Yeah, the next one is from Daniel Beust here from Germany. He's asking USB 2, not USB 3, Thunderbolt. I think also the thing that was discussed a bit on the Mio list, and also I saw this on Gearslats.
Sure.
Um, yeah.
And
Okay.
so the key to understand here is that what we presented at the Messe was a technology preview. It wasn't a specific
Mm,
product. It was a description of the technologies that we've been working on that become part of the baseline of every product that we do moving forward.
yeah.
So the thing is that what does that mean? What that means is that USB 2 is what we consider to be the baseline for the upgrade and for future products. And there's a few important points as why we chose USB as the baseline as opposed to USB 3 or Thunderbolt. The
Hmm.
first one is that every single device that you'd want to use with these, computer or tablet or phone, supports USB 2 and USB class audio.
Yeah.
And that's critical because the thing is that when this implementation is complete and it's in your hands, you'll be able to plug this device into pretty much anything and it's going to work.
Yeah.
Now, neither USB 3 nor Thunderbolt have class implementations for audio. So that means that custom drivers are absolutely required. And for the platforms that don't support custom drivers, that means that you cannot interoperate at all.
Yeah.
So,
Right. Yeah.
and also, honestly, USB 3 nor Thunderbolt have actually been implemented on pretty much anything except for the Mac and the PC. And Thunderbolt is something that is definitely weighted towards the Mac. I mean, there's a PC implementation and there are certain PCs that support it, but it's not something that is, a huge force on the Windows side of things yet.
Yeah.
Um, but you don't have Thunderbolt on an iPad. You don't have Thunderbolt on an Android phone. You don't have Thunderbolt on most Linux. Actually, I think on any Linux computer at the current stage of the game. Maybe that'll
Yeah.
change in the future. And you don't have USB 3 on any of those devices either. So, if you have a USB 3 device, you can plug it into a USB 2 host and it'll operate as a USB 2 device, but that means that you don't get any of the benefits of USB 3 either. So we decided that we would try to figure out what we could actually accomplish with USB 2.
Yeah, right. And
And
this is not bad.
right, and we've been able to implement an exceptionally capable transport layer on top of USB 2.
Yeah.
What that turns out to mean is that we can do 96 channels in and 96 channels out at 48 kilohertz, which means that it's a whole 192 channels total being transported back and forth between the host and the device. And that honestly far exceeds the needs of most of our customers, not everyone. And the thing is that what's important to understand is that when you're running at 48K, that's the channel count. If you're running at 96K, it's going to be half that. And if you're running at 192K, it's going to be half that again. So it's going to be, 96 channels, then 48 channels, and 24 channels. And there are certainly customers who really want to do more than 24 channels at 192K. But it's the exception. And the thing is that it is something that certainly doesn't really apply to any of the devices except for the computer, right?
Yeah,
I mean, it's not going to, you're not going to be doing, at least today, you're not going to be doing 192 channels at 192K on an iPad or something like that.
Yeah, exactly. Yeah, there's not many computers can handle that.
Definitely. Right. And so the thing is that, and then the fourth item about why we chose this as a baseline is that we have it all working now on USB 2. Now, that doesn't mean that we're not going to implement USB 3 or Thunderbolt. It just means that we're not ready to talk about it yet.
Exactly. Yeah.
And if you look at what we can accomplish on USB 2, that gives you some sense of what we might be able to accomplish on those higher bandwidth protocols.
Yeah, right. But I think that really also, as I heard the first time USB 2, I have similar concerns about the thing. And then we'd start discussing and think about it. And I must admit, yeah, it's definitely right. Because otherwise you pay for a very expensive protocol.
That's right. I mean, the thing is that the one aspect, and this is something that we were talking about how to communicate, but because the thing is that it's an upgrade, so that means that it's going to cost customers something to upgrade regardless. But the thing is that we can essentially include USB 2 for no incremental cost over the other elements of the upgrade, whereas USB 3 and Thunderbolt have real costs to both us and to the customer. So like I said, it's a baseline. It's something that you will see on everything that we do moving forward until it becomes clear that USB 2 is just like not any interesting anymore. And given the billions of machines in the world that support USB 2, I suspect it's going to be a while before it's no longer interesting.
Yeah, absolutely.
But that doesn't mean that's the end of the story. It means it's the beginning of the story.
Yeah, right. Exactly. Yeah. So it's nothing wrong with USB 3 or Thunderbolt, but finally, it's we have to pay for that. No? That's right.
That's right.
And the thing is,
the thing is that if you envision, if you think about the system that we've described, where you can hook multiple boxes together with MH-Link, you may indeed want USB 3 or Thunderbolt for one or maybe two of those boxes, but if you're using a large system, do you really want it for every box? Do you want to pay for every box, especially if you're not going to plug anything into it? Just some things to think about.
Yeah, absolutely. Yeah. I must admit, okay. Well, on the other hand, I will come later to that, because what is different with this USB communication there was another question, but I think we have addressed this thing here pretty well.
Yeah. Let's move on to the next one.
Yeah. Right. Okay. From Ralf Kleman. Will your FireWire ports remain, or will everything be swapped so that only the new USB MH-Link interface remain?
Yeah, so everything's going to be swapped. And the reason for that is that all the computers that support FireWire also support USB 2. So there's really no compatibility break. It's not like you're going to upgrade to this and, the computer I was using isn't compatible anymore, now I have to upgrade my computer. Anything that supported FireWire and is even slightly modern, like basically, I think anything that supported FireWire and ran OS 10 has USB 2. Absolutely. So, that's reaching further back than pretty much, anyone else in the world supports. And then maintaining support for FireWire would non-trivially increase the end user cost of the upgrade. And, given that new computers don't have FireWire, it's not a forward-looking technology, unfortunately, as much as we love it. It doesn't really make sense for us to add that and increase the cost for something that people at most would use for another year or two, and offers no benefits to them over just transitioning to the USB.
I can't resist to make a small comment that most of the Thunderbolt interfaces are FireWire interfaces. Huh?
Well, yeah, I mean, I don't know if that's necessarily the case for all of them, and I don't know if it's the
Yeah,
case for like some of the newer ones, but yeah, there's definitely some out there that basically
yeah,
have a FireWire bus internally.
yeah, right. Okay, yeah, next question. That is also an interesting idea. Um, from Bernhard Frank. When I connect multiple computers, which will show the Mio mixer, all of them, is one the master?
Okay, so we're still working on this aspect of the system, and I am going to defer answering this question until we have a more complete story to tell.
Yeah, yeah,
I,
right.
the 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 goal is for it to be something that is, you know, as close to ideal as we can make it. But I don't have a complete answer for you right now, so we'll just have to move on.
Okay, maybe we put it on the list. Huh?
Yeah,
Okay, then same from him. Next question: can a record to two computers at the same time for redundancy?
for redundancy,
Yeah, redundancy. Yeah,
yes,
right.
absolutely. It will definitely be the case that you can plug multiple computers onto the various, well, two computers at the same time, assuming, more than one box, right? So you'll have more than one USB port. You'll be able to plug multiple computers into multiple USB ports, and they will all be able to see all the channels, so you can do backup recording with multiple computers,
So that means also, for example, an iPad.
for example.
Great
Exactly.
idea. Nice thing. Nice thing. Okay, that's cool. Um, okay, next question. This was from Gearslats, a user called ProPower. That concerns just the latency thing. He asking one sample per digital connection, router, MH-Link USB, and he was asking, yeah, what is the overall latency? How's the latency concept of this box?
Okay, so his description of the situation, which is that the one sample that we've been quoting, is correct. It's
Mm-hmm.
one sample from the MH link to the router, one sample from the router to whatever the output is.
Yeah.
So that does not specifically apply to the transport between the computer and the box over USB.
Mm-hmm.
So I'm just going to read the next part of his question. He says, the numbers that we do not have explicitly are USB in to DAW or DAW out to USB. One sample would be historic, and as far as I know, not possible.
Yeah.
1 millisecond in each direction would be the usual lowest USB numbers I've ever seen. Don't forget A to D and D to A. So
Yeah.
that is correct. The actual USB latency is higher than one sample, obviously. In particular, USB uses 125 microsecond isochronous periods. So that means that every 125 microseconds, USB is going to transmit an isochronous packet or receive an isochronous packet. And so latency on the USB bus is quantized in units of isoch periods. In our implementation, the short clock implementation, we need to have 2 packets plus a couple of samples of safety offset on the input and output side of the USB. The 2 packets correspond to 250 microseconds of latency in each direction. And on the computer side, there's some additional transport latency due to the way that the USB hardware works. There's 2 or 3 packets worth. So that's an additional 250 to 375 microseconds or so. So
Okay, they move in a bit, depending on what is happening on the computer right now. Or
yeah, it depends on exactly how the driver is implemented. And, for
okay.
example, a driver that we implement might have a slightly different characteristic than the class driver. So,
Mm-hmm.
that needs to be fully characterized for all the different class drivers that are being used. But
Mm.
it's something on that level. So
Okay.
the thing is that if you think about it, you have like approximately 4 of these 250 microsecond latency buffers, plus maybe a
Mm-hmm.
couple of extra samples. So yeah, it looks like around a millisecond round trip between the sort of the buffering on the computer and the router on the box.
1 millisecond. Wow.
Now,
Yeah.
on top of that, you also have the audio buffer latency of the host, and you
Yeah.
also have any of the latency that's in the converters themselves. So,
Right. Yeah.
the total round trip latency is going to be dependent on which version, which box it is, and
Hmm.
also even more dependent on uh, the actual buffer size that you choose in your host. So, the thing
Yeah.
is that the audio buffer latency is roughly 2 to 3 times the audio buffer size, depending on how the host operates.
Yeah.
It's
Yeah.
either
Exactly.
it's either 2 or 3.
Yeah.
So, two would be, if you have a 32 sample buffer and it's two, then that would be 64 samples of buffering. That's about a millisecond and a half at 44.1. Um,
Hmm.
if it's a 128 sample buffer, then it's obviously doubled in size, and you're up to 3 milliseconds. Now, so as it turns out, the transport latency over the USB adds up to around 1 to 1.5 milliseconds at all the sample rates, and this is consistent with what we were able to achieve on FireWire as well.
Yeah. Yeah. What we got right now. Huh? Yeah.
Mm-hmm.
Interesting. This is pretty fast. Absolutely. Yeah. Yeah. Okay. Yeah. And I think that leads to next question. So very exciting stuff. Love the Ethernet connectivity. Love to hear the details on USB in-out latencies. I fear the one sample stuff is being taken way out of context. Yeah. And
Yeah, so
yeah.
the thing is that that's true about the USB to computer latency. Obviously, that's higher, and that's just a limit of the fact that you have a packetized system.
Hmm.
And in any case, the computer latency, no matter what the transport is going to be dominated by the buffer size that you choose for the host, right? I mean, at a minimum, you're talking about like a millisecond and a half for the smallest buffers that most hosts can handle.
Yeah.
And honestly, most hosts don't really do that well at those buffer sizes. So essentially, what you're talking about is like small increments to the latency defined by the computer buffer. But the thing is that this one sample stuff with regard to the latency of the 2 samples per hop, one sample for the input to the router and one sample
Yeah.
from the output of the router, on the
Yeah.
box to box connection is much, much lower than anything that we can achieve with other high bandwidth transports,
Yeah.
and
Right.
allows for
Right.
aggregations in a way of the boxes in a way that we cannot achieve with USB FireWire or something like Dante, as far as I
Yeah.
know.
Right.
As far as I know. The
Yeah.
latency would
Absolutely.
be
Yeah.
achievable with something like MADI, but MADI doesn't have the channel counts that we can attain with MH-Link, nor does it have the bandwidth for control data, and it has much more expensive and less generally available cabling.
Yeah. Yeah.
So, what we think that what MH-Link does for us, and the exciting thing about this one sample aspect, is that it allows us to take more than one box and make them look like one box to you,
Yeah.
without having routing latencies, large delays, overall, I mean, for example, let's say that the latency was 1 millisecond per hop as opposed to one sample per hop
Hmm.
or two
Yeah.
samples per hop, right? And let's say that you wanted to use 8 boxes together. You want to do 64 channels. That would mean that in order to delay compensate everything, we'd have to have a minimum of 8 milliseconds of additional system delay. So now you add that to the 3 milliseconds or so, or 4 milliseconds that you have for the USB transport. And now
Yeah.
you're up to like 10, 11, 12, 13 milliseconds, and that's too much,
Then you get a problem. Yeah.
right?
Right.
Whereas if we are only talking about 1 or 2 samples per hop, then with 8 boxes,
Yeah.
maybe we're talking about 16 samples. Even at 44.1, that's like 300 microseconds, uh, like a third of a millisecond. And you add
Yeah.
that to
Yeah.
the USB latency and the buffer latency, and it's not too much. So
Yeah.
that's what the whole point of the one sample stuff is all about, is that it
Yeah.
allows us to aggregate the system without adding substantially more latency over time.
Right, right. And yeah, right, today I figured out a very, very good example how this can benefit for everyone. Because I have here a drum machine from Arturia, the Spark.
Mm-hmm.
And if I want to run this on a very low latency, it really eats my computer.
Right.
So I took one of my old laptop as a MacBook that I got with the old one of the first Intel chip version thing,
Yep.
installed it there. Well, then I need a converter.
Mm-hmm.
And this thing has a converter latency. Then I go out of this box into the next one and so on. If I imagine I connect this thing to this MH link,
Mm-hmm.
it's awesome.
Right.
suddenly I have this integrated in my sound and I have this direct feeling of those synthesizers that are going to play there on this box. Wow.
Right.
Yeah. Yeah, there's some huge potential there that's hidden inside those things. Great.
Now,
Yeah,
one thing that I just said, but I think it's kind of important with regard to the MADI as an example of a high bandwidth audio transport, but that doesn't get us everything that we want, is that it doesn't have the bandwidth for the control data. And the control data is a really important part of this system as well, right? Because the thing is that even though you have one connection to the computer, from your perspective, you want to be able to control everything in all the boxes. And so we need to have a fairly high bandwidth path between the boxes to allow us to transport the control data around and the meter data and all of that sort of stuff so that you can insert your plugins and you can look at your meters and all of that without it feeling like, oh, I just went and tried to dribble, a large amount of information through a very small pipe.
Yeah, right, right. Exactly. Yeah. There's another aspect. Very pretty true.
Yep.
Yeah. Okay. Then the next question comes from Jan Gerhard. How is MADI integrated? And I think he asking how this goes into the box.
Right. So this one's sort of like the question about multiple computers being hooked up. We have the MADI technology done, and the realization for specific products is still being determined. So exactly which one of our existing products it would go into as an upgrade, or whether it would be a separate product, is something that we haven't fully determined yet.
Yeah.
And, if users have a specific desire or use case that they want to, share with us, then please feel free to send us an email and we'll definitely take it into consideration.
Yeah, that's definitely part of the Metric Header family. Yeah? Just drop an email.
That's right.
Yeah. Okay. Then also the next question from him is this real Ethernet connection? If yes, wouldn't it make sense to connect the device via internet to your computer?
Okay, yes, it is a real Ethernet connection. And yes, it is possible to connect via the computer. And that being said, the way that MH-Link works, it generates packets at a much higher rate than most computers really want to deal with. And there are some real challenges in getting the latency down to what we wish to achieve when using an Ethernet connection that is controlled and shared with a general purpose OS with a full networking stack. So, in addition to that, while it might not be the case for PCs on current Macs and iOS, current machines do not ship with Ethernet connectors on the hardware, so you would be back to needing to buy an adapter anyway, whereas that is not the case for USB. You can just plug it in. So, it's an interesting possibility of something that we might pursue in the future because we have defined the protocol in such a way that the computers can indeed see the packets and can actually format the packets. However, there are some challenges that are related to the fact that it's one sample of latency that make it a little bit rough to implement without dedicated hardware driving the Ethernet connection.
Yeah, this is an interesting aspect. I didn't know that, because what you shouldn't forget is with MH-Link, each of the MH-Link port is doing 128 channels at 192K. And this is a lot of data, of course. Yeah,
and it's also sending a packet every sample.
Wow, yeah, it's pretty fast.
That's how we can do one sample of latency, right? I mean, if we were collecting more than one sample, then the latency would be higher because it would be packetized for 6 samples or 8 samples or 48 samples or whatever, and each of those things would then increase the total latency that's being used by the transport. So the thing is that the packet rate is extremely high, and the way that general purpose OSs get good CPU performance for things like networking is they batch up the packets. And if they batch up the packets, then latency goes right out the window again. So that's the challenge. There's mechanisms in modern Ethernet hardware that was implemented for AVB that supports that. However, the OSs do not expose the APIs for interacting with the hardware on that level. They actually currently reserve them for use by the OS. So it's not something that's actually easy to access.
Yeah, right. I understand.
Yep.
Okay, then they understand why there's some of this network audio things like Dante or Render such a latency. That's very important aspect. Okay. Um,
Well, at least they have latency for the virtual sound cards,
yeah, yeah.
right? Which is essentially what he's asking about is a virtual sound card. You just plug it into the generic networking
Mm-hmm.
hardware
Mm-hmm.
and it works. Well, the thing is that then you have to they have their dedicated sound cards, and that in that they're doing somewhat similar to what we're talking about. They have a PCIe connection that goes to a dedicated transport engine that is shoveling
Okay.
out the packets at precise times, but it's not relying on the OS anymore to actually get that done. Yeah,
Okay.
yeah.
All right. Okay.
Oops,
That's another
sorry.
concept. Yeah. Okay. And yeah, this is also interesting. How can USB be superior to FireWire in aspect of CPU load and performance?
Okay, so modern USB hardware, which is, the XHCI and the EHCI, the host controllers that are plugged in, that are actually built into the computers, use the same kind of DMA engines that FireWire used. I mean, all of the audio transport, packet transport for USB is hardware offloaded. And the data transfer is done. Oops.
Please, sorry, say this again.
Are you okay over there?
Yeah, I'm fine here. Yeah,
Okay,
absolutely.
sorry. All of the data transport is done via DMA and does not require any CPU intervention. In addition, for USB audio transport, the packets are headerless, so there's no need to do payload extraction and header prepending for USB, whereas it is required for FireWire. So the actual CPU intervention is lower for USB than it is for FireWire for audio transport.
Okay, okay. Interesting. Didn't know that. Yeah. Okay.
So
And
basically, the thing is that all the things that would use CPU power are the same between FireWire and USB. And actually, there's one step that we have to engage in on FireWire that's not required for USB. So that actually improves things a little bit.
okay, okay. So it makes things easier. Oh, good. Okay, and it's also one of his questions is why is that high channel count not achievable with FireWire?
Um, well, actually, I think didn't he ask about the total channel count first? I think we covered this a little bit
Yeah,
earlier, but
yeah. We
let's
covered
just
this with before. Yeah,
let's just reiterate it.
yeah,
He's asking is 96 the total channel count, and
yeah,
it's 96 in and 96 out at 1x rates, so
yeah.
192 total. And then for each doubling of the sample rate, the total number of channels goes down by half. So at 2x rates, it's 48 in, 48 out, and at 4x
Yeah.
rates, it's 24 in, 24 out. Okay, and then he asks, why is that high channel count not achievable with FireWire?
Hmm.
Well, there's two components to the overall transport performance for interacting with computers. There's the capability of the computer and the capabilities of the device. And by device, I mean, like the Mio that we make.
Hmm. Hmm.
In the current Mio hardware, we implement the FireWire protocol layer on top of one of the DSPs. And a significant amount of the overall limitations are due to the CPU and bus bandwidth limitations for our current hardware. In addition, on the computer side of things, the number of DMA contexts that is required to support, I'm sorry, the number of DMA contexts that is required to be supported by a particular FireWire controller is fairly low. You
Yeah.
can pretty much only be guaranteed across all the hardware of having 4 input DMA and 4 output DMA contexts for isochronous, which means that you can only have 4 isochronous channels in and 4 isochronous channels out. Some of the controllers have 8 and 8 or 4 and 8, but it's not a guarantee and you can't rely on it. So if you want to sort of work from something that's reliable, it's 4 in, 4 out. And those two things, the DMA context on the computer and the bandwidth and CPU limitations on the current Mio,
Hmm.
combine together to limit the amount of total channels that we can stream and the total channels that we can stream to an individual box. Now, in
Okay.
contrast,
Hmm.
with the
Hmm.
short clock implementation for USB, we've implemented the USB transport layer in hardware without a software component. And that allows us to reach the actual channel bandwidth limit of USB. In addition, on the computer side, the USB controllers are specified to have enough DMA resources to be able to support all endpoints up to the bandwidth limit of the USB. So the thing is that the USB controllers that are built into the computer are simply not allowed to, say, have an arbitrary limitation on the number of isochronous endpoints they can support. They have to support all of them. And so the bottlenecks have been removed on both sides of the USB bus. While we could implement the short clock on top of FireWire as well, at this stage of the game, there's really no point because every machine that has FireWire also has USB, but many machines with USB don't have FireWire. Yeah. So we could make some improvements to FireWire if we re-implemented FireWire on the new hardware, but it's sort of pointless at this stage of the game.
Yeah, right. Absolutely, yeah. Okay. Yeah, okay. Very good. Okay, then we come to the question from Gert Bevin. First thing, what's the time frame?
So we're planning on shipping this sometime this year, and we will firm that information up when we can.
Yeah, right. When it's ready to go. Yeah. And what's the price? What's the cost?
We have not yet determined that because we haven't done a final board layout, but it will be affordable. Yeah. Just like, for example, the 2D card was affordable. Is it going to be exactly the same price? Can't say, but it's not going to be something that makes you go, oh, I can't believe that they just wanted to charge that much for it.
I think it will be more the other way around.
Perhaps. We'll see.
Yeah, we'll see. Okay. Can we have exact features?
Of course not.
Yeah.
I don't know if all of you folks out there have seen the movie Die Another Day. It was one of the James Bond movies, but there's a character in it called Gustav Graves. He's actually the villain. And as he said in that movie, it's not a secret, it's a surprise.
I like that. It's definitely that way, yeah. Yeah.
Yeah. So, you know, we're not in the position to give what all the exact features are, but everything that we've already discussed will be part of the product.
Yeah, right. Yeah, exactly. Yeah. I remember the thing as we talked before the show. We said, I do not know what we present, but it will be huge.
Yeah,
it was very nice. Okay, and how's it going to become available?
Okay, so for existing users, it will be an upgrade like the 2D card was. With a new motherboard and a new back panel. It will be field installable by users who feel comfortable doing it. And we will also offer a factory upgrade service through Metric Halo and through our distribution partners.
Yeah, yeah. And we made some good experience with that. I think 99% of the users made in the 2D upgrade did it.
Maybe 90%. You know, I mean, it's not something that's going to be difficult to do, but you know, you're going to be taking boards in and out of something that you've spent a non-trivial amount of money on. If you feel more comfortable with us doing it and making sure that it's done absolutely right, we'll be happy to do it for you.
Absolutely.
For a very small fee.
Yeah.
And then
no problem.
Once we're shipping this for new units, new Mios, it will be included as the base part of the unit and will not require a further upgrade.
Yeah. Right.
Just like we did with the 2D card.
Yeah. Well, okay.
And then he also asked, are there pictures? And
are there pictures? Yeah.
Not at the present time. In fact, the development hardware that we have is not representative of what the final product is going to look like. So it would kind of be pointless.
Yeah, right. I think some of the one who was on the show saw this, have a kind of picture of what it is about. But yeah, well. Yeah,
I mean, basically what it is, what the thing that we had at the show was, gave you sort of an indication, that the stuff is going to be in the box, but it actually didn't quite fit in the box, right? It stuck out the back a little bit. And, it's just something for us to finish the development of the hardware. And once we have completed the development of the hardware, we will actually push that into a board that has been purpose built for this purpose and fits perfectly.
Yeah, right.
Yeah.
Okay, then we have by Griffion. Griffion, I think, yeah.
If we've butchered your name, we apologize.
Yeah, sorry. Yes. How and where is the Plus DSP available, and how do we control it in class compliant mode especially?
Okay, so All of the processing that you have come to know and love on our hardware will be available on the new hardware, simply
Yeah.
with more available DSP. Now, there's some pretty interesting things about the way that we've implemented this that we're happy to talk about at the moment. One is that, for example, the FireWire transport engine consumed all of one of the DSPs in the box and about
Yeah.
15% of the other DSP on the 2D hardware. With SureClock, it uses no DSP at all. So all of
Yeah.
that
Yeah.
DSP power becomes available to us.
Yeah. Right.
The MH router, which we've described in the presentation that we gave at the Messe, would literally consume 100% of the 2D DSP. I mean, everything that you currently do on a 2D DSP, that DSP would be 100% consumed by the router. And on the new
Right.
hardware, it uses no DSP at all.
Yeah.
So as far as the specific forward-looking aspects of your question, we're still working on these aspects, and we'll share more when we can.
Yeah, right. We used to talk a bit about it because this it got a similar question. Finally, it means all those DAW channels are available in your Mio mixer.
Yep.
That means 96 channels in your Mio mixer.
Right. So, for example, if you're someone who's going and mixing on the Mio right now, and
Yeah,
you're like, oh, well, I have to make all these submixes because I only have 18 channels out, or if I go to more boxes, then chaining the boxes together is a real pain in the butt. Well, the thing is that those folks are definitely in for a treat because we're not
yeah,
going to be tying the transport engine for the USB to the boxes that are attached to the computer.
yeah, right.
So, for example, if you're someone who's doing the summing in the Mio mixer and you want to do a 48 channel sum, sure, why not? No problem.
Yeah, right, right.
Even with one box.
Yeah,
Right.
yeah, exactly. Just use this as a summing box.
That's right.
Um, yeah, we should discuss this on another tech talk because I have a talk with a customer has a very very interesting concept and developed a concept concerning the summing thing inside the Mio console, as he used sand waves to imitate the or emulate the leaking that you have somewhere in analog consoles. You
Oh,
know?
very interesting.
Yeah, very very interesting, and the results are outstanding. I
Awesome.
tried this here, but we should do this on another tech talk because this
Okay.
is definitely worth doing a tech talk about
Mm-hmm.
that. Okay, and I only have one box. Why do I care about this?
Okay, so there are 4 reasons, and
Yeah,
I actually wrote down 3 of them, and hopefully I'll remember the 4th one before I get to it because I forgot to write it down. Um, uh, the first reason is that this gives you interoperability with whatever platform you want to use at the moment. It does that without adapters, and it does it without, in a way that you're guaranteed that when you get a computer next year or the year after, it's still going to keep working. So you get to keep all of the wonderful aspects of the signal processing and the mic pre's, the conversion, the monitor controller, all that stuff, and yet be guaranteed that it will continue to work with the next computer you get and the next one after that.
yeah,
And if the next one happens to be, say, an iPad or a Windows machine, you can still work with that as opposed to with FireWire and the way that our system works. We're pretty much going to be Mac only on that hardware. Now, the second reason is that you get more of what you already love about the box: more processing, more channels, more plugins.
yeah, right.
Then the third one is sort of against the spirit of the question, but it's important because what this does for you is it allows you to have easy expandability. If you need more in the future, you can add more seamlessly. And for
Yeah,
example, if you work with let's say that you have one box and one of your friends has another box and you collaborate
yeah,
with each other and you need to do a bigger mix, you just plug them together and they work. It's
yeah,
not a matter
yeah,
of, oh, well, I need I need some special thing to make this work together, or I needed to buy the special expandable version and therefore what I have is no longer any good. So expandability is an actual benefit to almost
yeah,
anyone because people grow. Now,
yeah.
if you never need it, then that's okay. We're
Hmm.
not we're making it so it's essentially free to you anyway.
Yeah,
as
right.
part of
It's
the
included.
upgrade for all the other things that you want. Now,
Yeah.
I'm still kind of drawing a blank on what number 4 was. But it was kind of important. Oh yeah, now I remember what it was.
Okay.
So this really applies to people who are doing things that are more musical as opposed to technical, and in particular, like for example, the reverbs that we're doing, or want to be able to do things like musical delays,
Mm-hmm.
multi-second delays, that kind of thing.
Mm-hmm.
On the current hardware, we have a fairly substantial limitation in terms of the amount of memory that's available on the product.
Ah, yeah.
And
Yeah.
so, the amount of delay time that you can use is very low, and the amount of reverbs that you can use is like basically, I believe it might be two stereo or one stereo and three mono, something like that.
Mm-hmm.
It's fairly limited. I mean, it's enough to allow you to do some basic production work, but
Mm-hmm.
it's
Mm-hmm.
not a lot. It's not going to allow you to do, a full blown, large scale mix with
Next,
lots
yeah.
of
Yeah.
time domain processing.
Yeah.
And
Yeah.
we're still working out precisely how much memory is going to be in this
Mm-hmm.
solution,
Mm-hmm. Mm-hmm.
but at a very minimum, we expect it to be at least 1,000 times.
That's huge. That's a lot. That is definitely a lot. Yeah, that put the whole thing into a new perspective, I think, because I love the sound of the Mio mixer, must
Mm-hmm.
admit. And also, what I gonna do many times is just maybe doing some kind of 8-channel sub mix routing into the box,
Mm-hmm.
and putting there my hardware with the IO plugin, being sure of all those latency issues that sometimes the DAWs are a little bit flaky about that. Um, and I'm pretty sure that here everything is consistent. And
Yes.
whenever I open up a new song, I can route this in the same kind of structure and have basically the same basic sound. So it's a very, very smart workflow. But what really is pretty nice is connecting a Mackie control to it, and I just use the extender. And when I imagine this kind of huge mixer on one box doing this kind of 24-channel summing thing, routes maybe to 8 sub channels, like you have as a typical 24 to 8 to stereo desk.
Right.
You can do this here. And connecting a bunch of Mackie controls and just use the extender. Hey, man, you have the mix on your fingers. Awesome.
That's right. And
Yeah,
that
absolutely
that
awesome.
stuff all
Yeah.
exists today. It's
Yeah.
just that, going and expanding from 8 inputs to 24 inputs
Yeah.
causes a lot of extra complexity for folks, and that goes away
Yeah.
with this.
Apps. Yeah.
And
That's another
the
aspect. Yeah.
the time domain aspect that I just described allows you to do things like, system delays, or like I said, production type delays. So,
Yeah.
a feedback delay that has, a multi-second delay time, so that you can
Yeah.
do
Yeah.
things that are, tempo matched, that kind of thing.
Hmm.
And multiple reverb channels. So, you could
Yeah.
have a
Yeah.
reverb for the mix. You could have a reverb that you're using specifically for, the vocalists, so that they have a good sense of space in their headphones when they're
Hmm.
tracking.
Hmm.
And, all of this can be done with no latency.
Yeah. And it's nearly with no limitations in any direction. Huh? This
Right.
doesn't
Well,
matter.
that's and that, actually, that's a question that wasn't listed here, but but it's come up a few times as we've been talking about things, and I think it's probably worthwhile to
Yeah.
elaborate on. It's like, well, why are you putting 1,000 channel by 1,000 channel router at 192K in every box? The boxes
Hmm.
don't have 1,000 inputs and 1,000 outputs.
Hmm.
And the idea there is that basically that's sort of the natural size of the router, using the hardware that we're using. There's no inherent benefit to making it smaller as
Yeah.
such.
Uh-huh. Yeah.
And we don't really save any resources in doing that.
Yeah.
And the thing about it is that 1,000 is sufficiently big that it's essentially infinite.
Yeah. Right. Yeah. Exactly. Yeah. You have to remember right now we have something like 96 mixing points, no?
Right. Well,
And
and it's a little bit adjustable and that sort of thing. But,
yeah.
a big part of, for example, the complexity in the Mio mixer from the user's perspective is the fact that they have to decide what the mixer is going to be.
Yeah.
The reason that they have to decide what the mixer is going to be is so that they can get the most impact out of the hardware, because we aren't burning resources on things that they don't need. But at the same time, that means that they have to make decisions, and
Yeah,
those
yeah,
decisions that they have to make means that they have to think harder about something that might just be easier to do if we were burning the resources.
yeah, yeah.
So the point is that 1,000 channels of routing per box is sufficiently high that, I mean, let's say that you're doing a 64 channel thing, and all of a sudden, you need to do a couple more channels. Just, you have a guest vocalist coming in and you want to have a dedicated mic to it.
Yeah. Plug it in.
Assuming that you have the actual physical routing point, the physical A to D converter and mic pre, which could be added with, say, a ULN2, which is a very small box, right? Just add another 2 channels. The thing is that you're not going to hit with this system. Oh, well, I had 64 and that's the limit, so I can't do 66. Essentially, any normal configuration that any one of our existing customers is going to use is sufficiently smaller than the actual limit that the limit is effectively infinite. Whatever they need to do, they'll always be able to do it. And that is the reason that we chose to implement something on that scale.
Yeah, right, right. Yeah. Yeah, that's very interesting. What I'm very curious about is, finally, in this concept, even just with one box connected, we finally can listen the first time how these softs and stuff on the iPads are really do sounding on the iOS.
Yeah.
I'm pretty curious about, because right now, if you want to plug in something in your iPad, you have to go over a kind of conversion. And to be honest, this is mostly kind of consumer level stuff. Okay, there is some other brands having really USB class compiler interfaces, but integrated that way, I'm pretty curious how this will feel like. I'm pretty sure it's amazing.
It's something that we're very interested in exploring.
Yeah,
Absolutely.
yeah, really, right, yeah, absolutely. Yeah, and then we come to the last question. I think it's also very important. From Daniel Bost. Where can I get BJ's brains pilled? Need them urgently.
And the answer is, so do I. So sorry, no sharing.
Not will be included in the update also.
Maybe after we ship it.
Yeah,
I'll share.
after we ship. Yeah, we had some brain pills. Yeah, okay. I think that really covers the most urgent answers, questions from some customers. And maybe there was some more.
Yeah, maybe we can do this again as
Yeah.
things sink in on folks.
Well, just take the chance and take a look. Maybe in the meantime, there will be some addition, something else. Hold on a second. Right. Okay. Yeah, this is also coming up with questions. It was from Raphael Gruber, as he asking here. I think the internal 80-bit Mio mixer sounds better than any DAW. So my questions to you: how many channels could I send from my DAW to the Mio mixer to get better summing results? Yeah, that was the thing with the 96 channels. Huh?
Correct. Exactly.
Yeah, absolutely. It is true. It is that way. Yeah.
Yes.
You can do that.
Yes.
Yeah. Right. Man, awesome stuff. Yeah, definitely took me a week to get my head around that, and then I step by step understood it. And I can imagine that some customers are really in the same situation, thinking, okay, what this is in practice. Yeah.
Right. So, I mean, I guess the upshot is that, the point of us going to Messe and talking about this is, as people know, we don't tend to talk about things that we're not ready to ship.
Yeah.
And that's sort of generally our approach to things, but we thought that people kind of need to understand where we're headed, so
where we're at now.
So that they understand how their boxes are going to evolve and continue to serve them.
Yeah, right.
And that's what the point of that technology preview was.
Yeah, right. Yeah, and this is what I'm so curious about, is because we have those Mio community, really the Mio family.
Yeah.
And I was so curious what kind of ideas come around from them. And what I also like to say, what I realized there in the show, it was this, yeah, I have to tell this because this was very interesting. There come someone from another company come around to our booth, and I was presenting to another customer the new thing, and he just standing by and just listen, and then it was followed up by some discussion about things like technology, my studio setup, and how I gonna do this. And yeah, we have some chat about it, what kind of monitor control, speakers, and things like that.
Right.
And after this customer gone, and then this guy came to me and said, "You know what, guys? You got the best customers you can imagine." And
Ah,
I can
absolutely.
I can second this. We definitely have the best,
Yes.
absolutely, and was really I really enjoyed this to meet them all there on the show, and Musikmesse, and yeah, looking forward
Absolutely. It
for
was,
that.
it was great to meet people and to be able to interact face to face.
Yeah,
We haven't been doing a lot of trade shows for a while, so it's been a few years since I've had the opportunity to actually chat face to face as opposed to, over the internet with people. And it's always interesting what people think of, and how
yeah,
they're using things in ways that you never imagined. And it was very nice to, see how much people enjoy using the products.
yeah,
Absolutely.
absolutely, absolutely, yeah, yeah, great. Okay, let's see. Maybe there will be some more questions. Then we can do this again, and let us see. Let's do the next tech talk about those summing thing, because this is really an aspect I never had thought about, and this was an engineer from the UK figured it out, and maybe I can get him involved into some kind of Skype talk or something. We have to figure out,
Yeah,
but
that would
maybe
be
this
great.
would be interesting.
That would be very cool.
Yeah, great.
Okay.
Okay, thank you, BJ,
All right.
and
Again, and we'll talk again soon.
talk soon.
Take care, everyone.
Take care. Bye.
Bye.